Okay, good. So I'll start recording this class now. So we are looking at some numerical problem. So the first one we are starting with is the bisection method. The bisection method. Okay, so let's see how to go about it. Whenever you have to find the solution to an equation like what? For example, if you want to find solution to this equation, f of x equal to 0, like your polynomial. So you know that it's not all polynomial that we can factorize. So whenever you have been given a polynomial now that you cannot factorize, one of the methods they can use to solve it numerically is the bisection method. All right, now pay attention to this important fact about bisection method is that you see bisection method. We first, to start solving question of bisection method, we first find an initial root. Are we together? That is, we guess one initial root for us to use. Now, how do we get this initial root? Now, pay attention. We use what we call intermediate value theorem. Intermediate value theorem, IVT. We use this theorem, intermediate value theorem. Now, what is this theorem telling you? Remember, let's assume that we have f of x to be equal to 0. Now, pay attention. If f of a times f of b give me anything less than 0, therefore, a root lies between a and b. I'll say that again. Let me give you an example. See, if this is your polynomial, f of x to be 0, if you have two values, a and b, you now substitute a, you get f of a. You substitute b, you get f of b. If both of them have different sign, that is, I'm trying to say, if f of a and f of b, what I'm trying to say is that if f of a and f of b have different sign, if f of a and f of b have what? Have different signs. If they have different signs, this is what I'm trying to say. That is, a root will lie between a and b. That's what I'm saying. Do you get that?
Yes.
Do you get that? Good. Now, and also pay attention. Let me give you all the key points before we start. Also, since we know how to find the initial, that is, this intermediate value theorem, we are trying to locate where the root of the polynomial lie. That's what this theorem is for. You want to know where the roots lie. So if you know where the root lie, the next thing is that you start doing bisection method. And under bisection method, pay attention. At times, they give you what we call accuracy. What do you call it? Accuracy or error. It's given as epsilon, error. This one exactly. You see this error here? It's going to tell you, you see, if they did not give you this accuracy, your solution might not have end. You might just keep bisecting and so on like that. They will not give you accuracy at time. They can tell you that perform 4 iterations, perform 20 iterations. You can be asked to do that. But if they give you accuracy, the accuracy will tell you where to stop. Okay, good. So pay attention. Whenever they give you accuracy, how do we get the number of iterations? Now pay attention. The number of iterations, whenever they give you accuracy, you know the number of iterations you have to do. So what's the number of iterations? Let me say the number of iterations k is k. Pay attention. This k is greater than or equal to len b minus a all over this accuracy, then divided by len 2. This is how to find it. For example, look at this question now. I can say, look at this question now. Example, let me give you an example on something like that. I can say if L naught, which is equal to the absolute value of b minus a, is equal to 1. And our accuracy, E, some people can give you this way, is 10 raised to the power minus 6. Calculate the number of iterations. The number of iterations required. The number of iterations requires to make L of K be greater than or equal to E. Don't worry, I will tell you the meaning of this whenever we are doing our iteration. Don't worry. Remind me how to tell you the meaning of this thing. Because you see, there's this thing you see here now for bisection method. We call it stopping criterion. What do we call it? Stopping what?
Stopping criterion.
And this thing I'm giving you here is another form of this stopping. That is to tell you that when I need to stop this iteration, hey, you have to stop when something like this happens. Don't worry. When we get there. Okay. So this is what we have now. So how do we get the number of iteration? Now pay attention. Remember the number of iteration K solution. Pay attention. The number of iteration K must be greater than or equal to the length of what might be minus the absolute value. You have it 1. Have you now? Divided by what's my accuracy? My accuracy is 10 raised to the power minus 6 divided by length 2. So if you solve this one, you'll be getting check. Remember, we now have equal to. You'll be having something like this: K greater than or equal to 19.93. And check, what is that integer that is greater than this? That's greater than this. Remember that it's not possible for us to have 19 point something iteration. So therefore, just say your K is 20. Okay.
All right.
Yes, that your K is 20. Yeah. So if you perform 20 iteration, good. That's where you have your reasonable roots. Yes. So that's the stopping criterion. That is that. Okay. Let me give us a question on bisection method that will include that. See, if they did not give you this accuracy, surely the question will tell you the number of iterations needed. When they give you the accuracy, you are expected to first tell us the number of iterations, then you just perform the stop. And I'll tell you what this one means. Okay, let's go. Let's solve the question. Okay. I'm coming. I think I got some question. It will have gone down. Okay, look at this question. Okay, look at this question. And again, caution about something like this. If they give you any question on bisection method, for example, they say, okay, your f of x is something like x minus cos x. You now want to do bisection. Please set your calculator to radian whenever you are having trigonometry. Don't forget. If you use degree, that's failure in flying colors. Don't forget to hear. Because there will be no time for me to solve plenty examples. Find the root of. Do you get that point? Hello.
Okay, yeah, I'm with you now. I lost connection.
Okay, I said yes. Okay, so I said if they give you something like this, f of s equals something like x minus cos x. Look at something like this now. If you observe, trigonometry is there. I mean, cos. Yes. Right? Hey, make sure you set your calculator to radian. Okay?
Okay.
Yes. Please don't forget. Up to accuracy 10 raised to the power minus 3. They said, look at something like this. They gave you something. Let me give you that thing. They said initial interval. They said initial interval is 1,2. Then I say use bisection method. Now, please pay attention. If you understand this one example, you can understand the other example. But if you have trigonometry, put it in radian. Put it in radian. Don't forget, okay?
Yes.
Now pay attention to something. This 1 and 2, they don't give you. How do you get it? Remember, we have to use that intermediate value. That is, we want to know where the roots lie. Oh yeah, let me say they not give me this 1 and 2 now. Let's see something. Remember, my f of x is equal to s cubed plus 4x squared minus 10. If they give you your equation like this, x cubed minus 4x squared equal to 10, bring the 10 here to minus 10. So you now have s cubed minus 4x minus 10 equal to 0. Let me say this is what they give you now. Then you now call this your f of x. So I'm giving you different ways that question can appear. All right, after that, let me say they don't give you this interval. They have given you where the root lie already. If they don't give you where the root lie, now Firstly, start from f of 0 and test. F of 0 here will give me what? What will it give me?
10 minus 10.
Nice. Minus 10, good. What will f of 1 give me? 1 plus 4 minus 10. And that will give me what? Minus 5. What will f of 2 give me? That will give me 8. Plus, what will I have? 16 minus 10. And that will give me what? 14. We did give me 14. Yes. 14. What do you observe? You observe that between 0, you see, between s equal to 0, s equal to 1, there is no change of sign. I have negative, negative. Are we together?
Yes.
There is no change of sign. Therefore, roots cannot lie. Roots cannot lie between 0 and 1. Root did not lie there. But look at 1 and 2. 1 gave me negative answer, 2 gave me positive answer. Therefore, here, root lies between 1 and 2. Are we together?
Yes.
Exactly. Then this is how you are going to solve the question, assuming they did not give you this one. But this one they have given you. So what do? You bisect to, it means that there's root that lie between 1 and 2. Therefore, how do you now do? Now say x not equal to, you bisect these two, that is, add it together, divided by 2. And this will give you 1.5. Are we together?
Okay.
Good. That's your first approximation. That's your first approximation to the roots. Now, pay attention. You will now find, you see, I'm not interested in this number. I'm just interested in the sign. Now, let's find f of x naught. That's f of 1.5. Let's see something. Let's put f of 1.5. If I put 1.5 there, just tell me, will answer be positive or negative? After you bisect, after you bisect your answer, put it inside the equation to know what the sign will be. Oh yeah, 1.5 q plus, what will it be? Will it be positive or negative? And my calculator is not here. Do you have calculator with you?
Positive. Yes.
Okay, it's positive. Exactly. It means that it's positive. Since it's positive, tell me, it means that root lies between which one and which one? After this, I'll show you how to put it in table. Because all this, I just have to show you this way so that you understand what is going on. Root lies between which one and which one. Now check. 1.5 gave me positive. Go to the previous one. 2 gave me positive. 1 gave me negative. Please, which one will I use? I'm not using this 0. Remember, it's not even part of them. Now look at this.
Yes.
Which one will which one do you think the roots will lie between? 1.5 gave me positive. 2 still gave me positive, but 1 gave me negative. So which one will the root lie between?
1
between
and 1.5.
Exactly, 1 and 1.5. Why? Because they have different sign. Since root lie between this and this, bisect it again, you get x1. Bisect 1 plus 1.5 divided by 2. What's 2.5 divided by 2?
2.5 divided by 2 is 1.25.
1.25. Good. Now, when you get that 1.25, again, take f of 1.25. Like, do I have positive or negative? So,
It's negative. Negative.
Negative, Abby?
Yes.
Okay, negative. Now, what do you observe? Since negative, root lies between which one and which one?
It's negative. Root lies between 1.25 and 1.5.
Exactly. Between what? 1.25 and what? 1.5. Because 1.5 will be positive. Exactly. That's how you just be doing time again. So this is what we have. Oh yeah, next you bisect, that'll give you x2. And the process continues that way. Plus 1.5 divided by 2. What do you have?
1.37. 1.38.
1 point what?
38.
38. And so on like that. But wait, how do we know the number of iteration? That will be the first thing that I want us to even do first. So pay attention. Let me say that number of iteration, you have to just do it somewhere here before you start at top, okay?
Okay.
Before you start, let me just help you calculate. That number of iteration greater than or equal to, yeah, what do we have? Lane B minus A over what? Accuracy.
Over
Then
accuracy.
so I have to do, what's that my b minus a? That's 2 minus 1. This value given you here, that's 2 minus 1 over our accuracy is what? 0.
Accuracy is 10 raised to the power minus 3.
Okay. Then divided by ln 2. Please calculate it. Let me just do my calculator so we'll be following each other. Calculate it. Okay, what did you get? Hey.
Sir, I'm coming.
Okay, good. Means I'm doing it to sir.
.96. That's 10.
That's 9 points. That I heard. That's approximately
10.
Exactly. That's approximately what 10 iterations. Aha, nice. So we already know where we are going to. So you see the way the circle continues like that, like that, like that, like that. Now let me now show you how to put it in a table, because I would like you to put it in a table instead of doing all this. Okay.
All right.
Good. Oh, yeah. Let us see how to put it in tabular form. So you can just put your table in tabular form like this. So just show that iteration that, okay, so you are doing this iteration. Or if you don't want to calculate the number of iteration, don't worry. When we calculate that number of iteration, I will not tell you the meaning of this thing. So this first example, just to get the idea of bisection method, full idea. Now see, I'll not tell you the meaning of this stopping criterion. Stopping criterion, yeah. So this part now, where you can see maybe Sn, like maybe your number of iteration, let me say 1, 2, 3, 4, 5, 6, 7, up to 10. 7. Okay. 8, 9, 10. That's that. Next one is our, remember our A that we are using from beginning. They gave me interval 1, 2. So that A like that is just 1. Okay. They gave me B, right?
Yes.
And that's 2.
Yes.
B, sorry. I have my B and that's 2. Next one, how do we get C? I can just put the formula here like this. So to make it like comprehensive, that's B, C is equals to A plus B divided by 2. Even if you want to use Microsoft Excel, that's how you program that column.
Okay.
So it just help you directly, exactly. So that's just C. Next one, you have to find F of A to know the change of sign. You need to find F of B. Abina.
Yes.
F of C. I saw a question. They are asking them to show the error. That's the error. Something like the error. I'd like this to show itself. Let me just say the error. Or let me just say, okay, you see the meaning of this thing that is here. That is here.
So
this LSK,
stopping criteria.
Yes, exactly. This is it here. B minus A. Don't worry. Shall just hold on. It will make full sense. It will make full sense by the time. Let us just do all this table. All this thing, just sign that we need, not the number. Just sign. Okay, let's go. Remember our first. This one is 1.5. Abina.
Yes.
Yeah. This one is what? What was this? Before we get that 1 point, remember that I think one of them was negative. Which one was negative? One was negative, and these two This one was positive.
Yeah, f of 1 was negative. F of A,
yes.
negative. F of
Okay.
B.
What was f of 1.5? That's for that
F of 1.5 was positive.
Positive, thank you. Okay, what was my B minus A from here? B is 1, Abina.
Yes.
And don't forget the error they give us. Abi, let me write accuracy. Accuracy. That's 10 raised to power minus 3. And that's 0.001. Abi?
Yes.
Now, let's go. It's not missing. Now, what do you know? How do you know how to fill this next table? Pay attention. What will be your A and B? We always be among these three. Pay attention. You always be among these three. Anyone that give you different sign is the one that you pick. Okay? That is check. Remember that check. My F of C here gave me positive, Abina.
Yes.
So I'm picking my C. Now, inside this A and B, which one give me opposite sign to the positive that I have here? A. A will be good. So my A will not be what? That one will not be here. That's when I will say the root lie between 1.5 and 1. That will be my new A and B. And you can change it. You can put 1 here, 1.5, no problem. Let me explain this part again. Again, when you do all this, your C, you are picking it like this. After picking your C, how do you know the next number to put here? Now, look at which, remember that we must have different sign. Just check which of these gave you opposite sign to this F of C. My F of C was positive. So just look at the one that is negative. F of A is negative. It means that I'm picking A. I'm picking A. And then, so if I bisect this two, what do I have? 1.5 plus 1, 2.5 divided by 2, what do we have? Is that not 1.25? Right?
It's 1.5.
Yeah, you have 1.25 exactly. And then what is F of 1. Now, what's F of A? F of 1.5 is negative. Positive, I mean? Positive, yes.
F of 1.5 is positive.
It's positive. Oh, yeah, what of F of 1? Negative. Oh, yeah, what of F of 1.25?
F of 1.25. Negative.
Yes. Yes. And what's that equation we are dealing with? F of x equal to s cubed. What's that equation say?
Minus 4x squared.
Mm-hmm.
So x cubed plus 4x squared minus 10.
Mm-hmm. Nice. Oh yeah, what is that? My F of C?
So let's negative. Let me want to confirm.
I want to just program my calculator to that equation.
Negative.
Okay, that should be 1.25, right?
Yes.
Yeah, negative. Yeah, I just need this sign. Negative. Good. Oh yeah, now, what was this minus this? You know, B minus A absolute value. B minus A gave me 0.5. Abi now?
Yes.
Hey, this thing will make sense. So by the time we are done, yeah, let's go. What will be my new A and B? Remember, my C, you always use this your C. Like this C, you always use it. All together.
Yes, yes.
So that your C now is 1.25. Oh yeah, C was negative. Which of A and B will you pick that have opposite sign to that C? Which of them?
A.
A, Abi now. And what is that your A here? 1.5, Abi?
Yes, 1.5.
Sorry, 1.5, you're putting it here. 1.5, exactly. Oh yeah, bisect these two. What do you have? 1.25 plus 1.5 divided by 2. What do you have?
1.3, 1.38.
Is that everything that calculator gave you?
1.375.
Yes, let us use everything. 1.375 exactly. So we can get our correct answer. 1.375. But yeah, F of 1.25, of course, that's negative. You will see it here. F of 1.25, that's negative. F of 1.5, that's what? Positive. But what is F of 1.375? I've done it here. That's also positive. What was our error? 1.5 minus 1.25. What would that give me? 0.25.
Yes.
You will get it now. So that's for that. So in case they tell you to show your error calculation, this is what they mean. Yeah, let's go. Remember, we always choose by C, 1.375. We are C is positive. I'm picking the one that is negative, and that's 1.25. Then bisect these two. 1.375 plus 1.25 divided by 2. What would I give you?
1.3125.
1.375 plus 1.25.
Yes, divided by 2.
Okay, yeah, what do you have?
1.3125.
Yes, 1.3125. Where, remember, f of this one is positive. F of 1.25 is what? Negative. Please, if I'm making mistake, let me know, because let me see. This is positive, sure. My 1.25 is negative, sure. Next, 1.3125. F of 1.3125. Negative, thank you. Negative. And what's mine? 1.375 minus 1.25. So 0.125. Oh, yeah, look at this now. 1.3125. What again? Which one am I picking? This is negative. I'm picking positive.
Check. I'm picking F of A. That's 1.375.
Yes, 1.37. You observe this thing is converging. You see it's converging. How do you divide by 2? What do you have? 1.3125 plus 1.375, have we divided by 2? What would that give us?
1.3475.
4 decimal, please. Yeah, 4 decimal, please is fine. So yeah, let's go. Looking at this, 3125 is negative, 1.375 is positive. Then what of this? Answer cube plus 4 answer square is 10. That's negative. Abina.
Yes, negative.
Yes. And this one gives me 1.375 minus 1.3125. What do we have? 0.0625. Is at the end of this problem, everything will now be so clear. 0.625. So that's what I have. Next, what do we have? This one is negative. I'll first pick my C before anything. 1.3438. Then look at the one that have change of sign. And that is what? F of B. 1.375. Yes. F of B, yeah. 1.375 as change of sign. Okay, negative, positive. Okay, next, bisect the two. 1.3438 plus 1.375. Abina?
Yes.
Then divide by 2.
1.3594.
3594. Oh yeah, change of sign. This is negative. This is positive. Oh yeah. Both of this. Answer raised to power 3 plus 4 answer square minus 10. Negative. Negative. So 0.0312. Yeah, let's go. I'm picking my C, 1.3594. Then what else? Is negative. I'm choosing 1.375.
Yes.
Yes, because positive, exactly. So I'll bisect the two. 1.375 plus 1.3594. Then my answer divided by 2.
1.3672.
3672. So 1.3594 negative sign.
Negative.
This is positive. Yes. Then this one answer goes to power 3. All right, so I have positive. Let's give me positive answer. Then if I subtract it to 1.375 minus 1.3594, that gives me
0.0156.
156. Yeah, they're almost getting to the end of the iteration. Okay, let's go. Next, what do we have?
1.3672.
3672.
So we're going to pick 1.3594.
Yes. Yeah, I said it too.
1.3633.
1.3633. Then
Yes.
1.3672 have positive sign. 1.3594 has negative sign.
Negative sign. Yes.
Negative.
Yes, negative.
I cannot laugh. What do you have?
0. Come. Just
Oh,
1.359.
what do you have? 0.00.
0.0078.
Yes, 0.0078. Yeah, 1, 2, 3. Yeah, thanks for understanding. Nice. Next. We're almost getting to the end. Let's go. Next one. What do we have? What do we have?
1.3633.
1.633. Which one
And
changes?
to pick 1.3672.
1.3633.
It's negative.
No, 3672. Yes, I want to divide by 2 for us to know
1.3653.
Exactly. Let's go. What do we have?
1.3633 is negative.
This one is negative.
Negative. 3672 is positive.
Positive, yes. But this.
Positive.
Positive. Then what do we have? 1.3672 minus 1.3633. Yes. 0.0039. Oh yeah. Next, what do we have?
1.3653.
1.3653.
3653.
Then the one that has change of sign,
1.3633.
Next, what do we have?
1.3643.
Okay, you have divided by 2, I mean.
Yes.
1.36
43.
43. Really? I'm coming. Let me check something. 1.3633. Sorry. Okay, let's go. So what do we have? Positive?
For 1.3653 is positive.
This is negative. Yeah, what of this?
Negative.
Negative.
Negative, yes.
All right.
Minus 0.002.
I'm coming, my hand. There's something I want to tell you about that thing. Come down. Okay, minus 1.3653. Okay, just remove the 0. 0.002. Please hold on something. Remember that. See, let me tell you. this first iteration, let me tell you where it started from. It started from here. What you have here, like, let me say 0 iteration. We have not even started anything. Then we just start iterating by putting it in the equation. So I'll say this one start from 1, 2, 3, 4, 5, 6, 7, 8, 9. All together.
Yes.
You know that this one is just for us to know where the root lie. Then from there we start iterating exactly, which means that we have one more to do. Or if you don't want to do, maybe you don't want to put 0 here, just start putting 1. Maybe after you are soft, but do it this way is fine. So you observe that it not contradicts your number of iterations. Yeah, I just actually tested that to see. Then you now observe something. How I came about this. Yeah, let's go. Yeah, which one will I put in A and B?
1.3643. First.
No, that's 1.3643, and that was negative. So I'll pick 1.36.
1.3653.
Okay, good. Add it 2 divided by 2.
1.3648.
I'm coming with. Let me do it my mind. What does it get? 1.3648, I mean.
Yes.
Already convert. Yeah. So what do we have here?
For the 1.3648 is negative.
This one is positive. Yeah.
The other one is positive.
Okay. Answer Q. What do you have here?
Negative. Negative.
Yeah, let's subtract those 2. Let's see what we get. What do you have?
0.001.
This is where we have to stop the iteration. At the 10th one will be where we are going to stop. Now, observe something. We will now observe that stopping criterion now. What's that stopping criterion? Don't forget. The stopping criterion is that stop when L of, what's L of K? K means that, observe, what does L mean? L means the difference of this and this, okay? You can see some people write this one as L, okay now?
Okay.
So it's like you're saying B minus A at the K iteration must be less than or equal to the accuracy they gave you. Now, come and see. You can see B minus A at the 10th iteration. See our B minus A at the 10th iteration. What do you have? Is it not less than or equal to 0.001? Our accuracy. Do you know so that? So whenever you have a value that's equal to the accuracy or less than it, then we have to stop the iteration there. That's the meaning of that stopping criterion exactly. That is what it means. Okay?
Yes.
So approximately, we can now say, okay, our root is now, where is it? Where is that C? Can say our roots, approximately this guy. Or let me say lie between, or you can say, okay, where the root lie between this, which is negative, and this, which is positive. Are we together? Yes. Or if we want to find one approximate root, just tell them approximately this is our root. Yes, approximately this is our root. Okay. And at times, okay, let me conclude this way that therefore the approximate root is equal to 1.3648. And I'll need to add some error to it. And what's my absolute error? My absolute error is half of maybe A minus B, or B minus A, anyway. So what do we have? 1/2. What is my A? A minus B. What do we have?
0.001.
Yes, 0.001. And what's my answer?
The answer is 0.0005.
Exactly. So that's my answer. Then you stop there. So that is it. That's it. So that you can see bisection and the convergence is slow. You see, your own personal work is that you go and find the disadvantage. If you observe one of the disadvantage, one of the advantages is that always convert to solution. You understand? If you use the right initial gain, yes. And also one of the best advantage of bisection method that was doesn't involve derivative.
No.
You know that to differentiate is one of student problem. So one of the advantage of you can just now advantage of bisection method that way, it does not require derivative of the given function. Okay, it does not require. Yes, exactly. So and the disadvantage is that what slow convergence. Disadvantages of bisection method. No, but this is the main one, slow convergence. Always take time. Okay, and so on like that, you can just find other one. And advantages is that no derivative is required. That is, there's no derivative of the function, no derivative is required. Yes, that's advantage. Another advantage is that always converge. Always convert, but it can still take time. Always convert to a solution. All right. So that's that for that. Please give me a second. Let me take something to plug my phone. Okay, so that's bisection method. We have many iterations to look at. So after bisection method, another important thing that we look at is fixed point iterative method. FBI. Okay, so let's look at the fixed point iterative method. Okay, pay attention. Whenever you have to solve using the fixed point iterative method, this is what we do. Remember that we want to solve the equation. We have the equation f of x to be equal to 0. See this equation that you have. Look at the step. Put the equation above in the form x equal to g of x. Don't worry. Put the equation equal to what? X in this form, x equal to g of x. And pay attention. You see this x equal to g of x that you have here. You can have several ones. It's possible that one equation can give you about 3 of this form. Can give you about 3 of this form. All together?
Yes.
Good. So after you do this, I'll tell you how to know the one that you are going to choose out of those ones. I'm coming. Give me a second. Now, remember I told you that this one can give you several ones. So choose now. Choose g of x that satisfies this thing I want to tell you. Absolute value of g prime of x less than 1. Absolute value of what? G prime of x less than what? 1. This thing I gave you here now is like the condition for the convergence. You see, if you choose g of x like this, that obey this thing, it will converge very, very, very fast. But if you choose the one that is otherwise, it might not converge. And if you choose another one again, it might take time to converge. So again, put your equation in this form, s equal to g of x. Next, choose the g of x that satisfies absolute value of g prime of x to be less than 1. So when we do that, what do we now do? Then we now write the recurrence equation. Then we write something like this. You know what they call recursive formula? Have you heard of something like that? That is a recursive formula like this. Then you now define, let me write this way. Then define a recurrence, then define a recurrence relation. What that recurrence is that from here, xn plus 1 equal to gxn. Then from there, you start iterating. How do you know where to stop here? What is stopping criteria of this one? When any root repeats itself, that's all. A root will repeat itself, then that will be your approximate root. Now let's look at this example. It says find the roots of this equation, s cubed plus 4s squared. That one that we solved.
Yes.
So we plus let's do the same. Minus 10 equal to what? 0. So using this fixed points iterative method. So using this point iterative method. Oh yeah, let's go. What do we do first? Yeah, let's follow the step. What did I say should do first? Put the equation in the form s equal to g of x. Have you now?
Yes.
Now see different ways that I can use and do this thing. Firstly, I can decide to make my s cubed the subject of the formula. Check, I'll be having s cubed equal to 10 minus 4x squared, isn't it?
Yes.
Then my x cubed, it cannot become cube roots of 10 minus 4x squared. So this is like 1. This is like 1. This is like one way to do it. Are we together?
Yes.
So let me call this one g1 of x. So that's, I've gotten one of this. So keep this one somewhere. And another student might decide to say, okay, let me make my x squared the subject of the formula. So I'm having 4x squared equal to 10 minus s cubed. And if I divide both sides by, I'll be having x squared equal 1 over 4, 10 minus s cubed. And therefore, from here, I'll be having x equal to square root of 1 over 4 is 1 over 2. Then 1 over 2 square root of 10 minus s cubed. That is another way. So let me call this one g2 of x. That's another. Remember, I told you something here that this thing, we can get up to 3 or 4, depends on how the equation look like. Also, another student might decide to say, okay, I don't want my own to be like that. Let me factorize x away from this place. And that's they can say that, okay, let me factorize. You know that the maximum amount of x I have here is x squared. I can factorize x squared away and say I have x plus 4. Then equal to 10. So I have x squared equal 10 divided by x plus 4. Have you now? Yes. Then from here, what do I have? X equal square root of 10 minus all over x plus 4. So this is my g3 of x. Now the thing is that check. I've gotten g1 of x, g2 of x, g3 of x. Now after getting out, there's no other way I can get this one again. Yeah, I think it's okay like this. Now the thing is that how do we know the one to use? We will now come to the next step that choose the g of x that satisfies this. Yes or yes?
Yes.
Oh yeah. Let's see the one that g prime of x will be less than 1. Oh yeah, firstly, let us come on. You can do it in the next page, but I want to just do it here. You understand? Maybe if you are solving yours, you get it. Hello? Yes, g1 of x equal to, I have 10 minus 4x squared, cube roots, I can write as 1 over 3. Yeah, let's differentiate. How do we differentiate? You can see why, you can see disadvantage of this one, differentiation. This is how you differentiate this. Bring down the power, reduce the power by 1. If I reduce 1/3 by 1, I'll be having minus 2/3. Then multiply by the derivative of what is in the bracket. If I differentiate 10, that's 0. If I differentiate minus 4x squared, that will give me minus 8x. So G1 prime of x equal to minus 8/3x. You observe that what is here is less than 0. That is less than 1 rather. Is less than 1. Is less than 1. Why did I say is less than 1? Why?
Because of that negative sign.
Stop. So, okay, wait. I'm coming. Wait. Don't let me jump. Wait. Let me reverse. What's the absolute value? I'm coming. What's the absolute value?
8/3x.
I have to look at what?
8/3x.
8/3x. 10 minus
4x squared.
this power minus 2/3. I mean,
wait, did you remove that minus?
What is it? Yes.
Minus,
Yeah.
No, not that one. Not that one.
This one.
The minus 2/3.
Yeah. Okay, minus. Okay, yeah. No, you have to put it. No, you can't remove it too. You have to minus 2/3. Pay attention. Remember something. How do we know if this one is greater than 1 or less than 1? Now, pay attention. Remember, see, I want to do something. We have to substitute one x value here. How do you know the x to substitute? Just pay attention. Remember, see, I have to do a particular work in here. Hold on. See, what is mine? Let us check f of 1, just like we did our bisection method. I want to just know where the root lie here. My f of x is s cubed plus 4x squared minus 10. Remember that in the previous example, our root lie between 1 and 2. Abina. Shibi? Hello, right? So I have x not equal 1 plus 2 divided by 2, and that's 1.5. So take 1.5 here. So at s equal to 1.5, what do we have? Yes, that's my x naught. So what do we have? Yeah, punch this into your calculator. Let's see.
Four.
What do you have?
4.
4. Check. We have 4. Definitely, this is greater than 1. Never. If I use this one, if you observe, if I use this one, you observe that is going to it will give me a solution that will diverge. That what?
Diverge.
It's diverge. Yeah, it will not obey that condition. Let's go to the next one. G of 2x. This I'm showing you how to know, how to differentiate, how to know the one you are going to be. Now, what's G prime of G2 of x? Yeah, let's go. Look at it here. So we want to differentiate this. First, we have half.
Yes.
We now want to differentiate square root. Square root is like you bring down the half, reduce the half by 1, then multiply by derivative minus 2x minus 3x squared rather. Then absolute value be equal to, I have 1 over, that's 3/4. I'll remove the minus. I'm coming. 3/4 x squared. 10 minus s cubed raised to power minus 1/2. We are at x not equal to 1.5. What do we have? Okay. So what do we get?
0.6556.
0.6 556 or anything. Observe, this one is less than 1, right?
Absolutely.
Good. Let us test the third one before we conclude finally. Let's test the third one for us to conclude. So G3 prime of X, what will this give us? Looking at this one, I can rewrite it in this form. I'm coming. I can just say, okay, I have square root of 10 somewhere. Then I have X plus 4 raised to the power minus half. This is what I have. So let's go. So this is what I have. Therefore, what I'm having here is that I have square root of 10, then bring down the power minus half, reduce the power by 1, minus 1, minus 3 over 2, then derivative of what is in the bracket, that's what? 1. All together?
Yes.
Then we are put the absolute value, G3 prime of X. What do we have? Minus that square root of 10. Square root of divided by 2. Then X plus minus 3 over 2. Oh yeah. At X not equal to 1.5. What do we have? Oh yeah, let's go. Oh yeah, let's go. What do we have? Check. G3 prime of X is equal to, let's go.
It's less than 1.
So what do you get?
0.1226.
0.122 what?
So 6.
Now observe, this is also less than 1. Now, which one satisfies the condition? Both of them satisfy the condition, Abina. But which one do you think will be the best one to use that will quickly converge? The one that is more than 1. Exactly, and that's what G. If you observe, if I use the 2, this one will converge slow. It will still converge because it satisfies the condition to convert slow, but this one will convert faster. Let me say this one can convert at the 4th iteration. This one can go and convert at the 9th iteration, something like that. Why this first one that did not satisfy the condition will never converge? It will diverge. Okay. I'll get that.
Yes.
So that's it. So let us now. So since we are using that one, therefore we are using X plus 1, Sn plus 1 equal to G of Xn. Abina. And what's our G of F for the third one that we are using? The third one that we are using. Oh yeah, what's that third one that we are using? What's that third one that we are using?
X equals to
square root of 10. Abina.
The square root of 10 over X plus 4.
So square root of what? 10 over Xn plus 4. Exactly. So whenever you have X, so this is what we are solving now. Now, okay, we can use our tabular form. I don't want to just show others because this one is faster with calculator, you will see. We don't know the number of iterations it will give us yet. Let us just check it out. So let me say N G of Xn X okay, well, do you need to write? Just say, don't worry. Let me just do it this way. I'm coming. I'm coming. I don't need this big active, just something small. It's okay. Okay, I'm just doing it for one of them, not all of them. Okay, so see what I have. This N, my iteration, and we have G of Xn. Xn plus 1 equal to square root of 10 over Xn plus 4. And remember, pay attention. See what we are going to be doing here. At n equal to 0, I'll be having my x1. Abina.
Yes.
What will be my x? My x1 will be equal to, remember, this one become x naught. That is check. If I say at x equal to 0, what I'll be having here what? X1 equal to, at n equal to 0, rather, n at n equal to 0. If I put 0 here, I'll be having 1. It will become x1 equal to g of x0, and that's square root of 10 over my x, and that become x0 plus 4, which means that my x0, I have yeah, put x0 there. Now configure your calculator. Configure your calculator. Just say square root of 10 all over alpha x plus 4. Do you know how to configure that calculator now?
Yes. Yes.
Then press calculate. My x is 0.5. You put it there. What's my answer? No, our x is 1.5. Sorry. What's my answer? Our first initial guess. So what do you have?
Sorry, I have to confirm something.
Okay.
Our x1 is just 10 square root of 10 over x naught plus 4.
So that our x naught is that initial guess, which was 1.5. You get that?
Okay.
Yes. So the same way we get initial guess. In fact, it's for all of them, say, even if you are solving from bisection, Raphson, fixed iteration method, all of them, the same initial will guess. Intermediate value theorem, don't forget. Yeah, this one I have 1.3484. Wait, don't cancel your answer, don't cancel your calculator. Now, press equal to, it will bring the value of x again. Now, pay attention. At our first iteration, if I say at n equal to 1, what I'll be having here what? X what? X2 equal to g of x1. And that's like square root of 10 all over x1 plus 4. It means that the x I'm using in this new iteration here will be my previous x1 that I got. Are we together?
Okay.
Yes. Let me do this. I want to. Maybe I should be showing the x. Let me do a table to show the x, please. So it's more explanatory. So we won't be cramming it. I'm coming. Please, let me just show you a table for the x. I'll make my x 4 decimal, please. Okay. So this is my, like, how do we put this on? Let me say x n plus 1. And this is my g of xn. G of xn. And that's square root of 10 all over xn plus 4. Pay attention. X, this one at x equal to 0. All together?
Yes.
Remember, I have initial guess, and that is just pay attention. This will be my x1 at n equal to 0, and x equal to 0 here. What I'm going to use here is my x naught. And don't forget my x naught. My x naught is 1.5. I've been
1.5.
Yes. We have put your 1.5 there. What do we have? We have a value before, and that was what?
1.34.
1.34 from calculator. 1.34. 84. Have you now?
84. Yes.
Good. At n equal to 1, my xl was x2. Have you now?
Yes.
Good. Now pay attention. Remember that my x2, by the time I want to get my x2 here, you see that what I'll be using in this place will be x1. Abi?
True.
So, and that x1 was my previous answer here. Abi now?
1. Yes.
Exactly. So it means that if you press equal to and that thing asks you the value of x, just press answer for the previous one. So you'll be getting a very accurate result because we'll be using all the value. You understand?
Yes.
Equal to
1.36.
1.3674. Abi now?
Yes, 74.
Yeah, equal to, press answer again. What do we have? 1.3650. Abi now?
1.3650. Yes.
Yes, equal to answer. What do you have? 1.3653. Equal to answer. Yes, 1.3652. It has not converted. Equal to answer. 1.3652. Do you see that? What do you observe?
That's repeated root, and that's
Exactly.
that's the
You
stop.
can see this one convert at the fifth iteration. Do you see? So therefore, if the root has repeat twice, therefore the approximate root is what? 1.3652. Have you now?
Yes.
Oh yeah. When we use bisection method for this same question, what did we get? When we use bisection method, what did we get?
1.3648.
48. Do you see that? It's observe 3648. Add this error to it, be like 3649. And you can see that at least the value are agreeing with each other. Have you now?
Yes.
Yes.
If I add that error,
okay.
if I add that error, it's going to be
yes.
1.3653.
1.36 what?
53.
Let me see.
So it's very, very close.
Let me see.
If I add this,
okay, wait. The error is true. Check. 1.3648 plus 0.0005. Oh yeah, what do you have? This give me
1.3653.
Exactly 1.365. Do you see now? That is why this error is very important. You show that at least this is our answer. Then it should be at least plus or minus 0.005. You understand? Yes. That's the importance of the error. So you can see that the workings are accurate. And you can see that this one is fast. This one bisection method, which one is easier? And which one converge faster? Bisection method convert at the 10th iteration, but this one fifth. In fact, there are some methods that I don't want to teach you because those ones, they are just too long and unnecessary. They are just too long. They call that Aitken's accelerated convert. It can convert at the third one, but the working is so long. Okay? Let us just waste time on that one, please. Let us waste time on that one. Okay, that's that. Do you understand? Do you understand the conditions of this now?
Yes, yes.
Nice. I'm coming. Okay. Next, we want to look at. Let's go to what is important. Let's go to Raphson. Raphson.
Hey.
Wait, are you exhausted? This is the most simple, like it's the easiest step. But we did Raphson in MT102 now. Hello, are we together?
We are together.
So after this Raphson, wait, in 305 last semester, that teacher you put Jacobi iteration method. What was it you put? I thought. No, it was part 4. Was it Jacobi and Gossedel? No.
Jacobian method.
No,
yes.
I mean Jacobi. That one that has to do with matrix like this.
Draw it first. Can you draw it first?
No, if it was not you can remember, it's part 4. It's part 4, not you. I can remember it's part 4, not you. You know that maybe after Raphson, what's the time said? In fact, it's even past. Maybe after Raphson, our next class that we are going to have, maybe whenever you are available, just let me know. So we'll be having this class back to back. Our next class will be on Jacobi iteration method and Gossedel's method. Then after that, we'll be done with this one. Then we'll be moving to interpolation and polynomial approximation. You get?
All right.
So let's look at Raphson by 2 scientists, Isaac Newton and Joseph Raphson. So, what's the main idea about this? I'm coming. For the Raphson method, pay attention. If I have, you have an equation that you want to solve, f of x should be 0. By Newton's method, they can call it Newton's method, Newton's Raphson. By Newton's method, what do you have? This is the formula we make use of. X of n plus 1 is equals to xn minus f of xn divided by f prime of xn. F of xn minus f prime of xn. This one involves derivative. Wow. Okay, solution. Let us look at an example. Let's solve this with interaction. Let's solve that our equation, that one that we solved. F of x equal to s cubed plus 4x squared minus 10. This is the equation, right? Are we together? Hello, are we together? Hello? Hope you've not lost connection. Hello, you left the class, like, right?
No, my network is connected.
Okay, I'm coming. Let me see.
You've written a lot.
Yes, don't worry. I will stop at Raphson, yes. Because this thing that there are a lot. I'll stop at Raphson, don't worry. So looking at this, I want to solve that question that we solved with bisection, fixed point iterative, and this. Okay, so let's solve by Raphson method. This is the formula. This is own formula. Now pay attention. Observe here. I will have to differentiate because in the formula I'm having derivative. So what's f prime of x? What do I have? 3x squared plus 8x. Nice. That's what I have. Okay, after getting this, don't forget, I know you have to test where your root lie. But we have been solving this equation. We already know our root lie between 1 and 2. Are we together?
Yes.
So if this is my f of x, therefore f of xn will be what? Xn cubed plus 4xn squared minus 10. And this is my f prime of x. So what's my f prime of xn? That was 3xn squared. Wherever I see it, just put xn plus 8xn. Then we have xn plus 1 equal to xn minus, what is my f of xn? Xn cubed plus 4xn squared minus 10 divided by 3xn squared plus 8xn. So my own is that I love to put this thing as a simple fraction to make my work easier. So just, look at something like this. Are we together?
Yes, yes.
If I have 3 plus 1 over 5, how do we do this fast? 5 times 3 plus 1. 5 times 3, 15 plus 1, 16, that's 16 over 5.
16 over 5. Yes.
Yeah, that's why I did it. So same thing, I'll do this one. This times this, that will be 3xn cubed plus 8xn squared, then minus the whole of this, so be minus xn cubed minus 4xn squared plus 10 divided by what? 3xn squared plus 8xn.
Plus 8xn.
Yes, I love to do my work this way, sharp. Equal to, what do we have? This and this is giving 2xn cubed plus 4xn squared plus 10. Wait, is this plus 10 or minus 10? What? Okay, yeah. It has changed sign. Plus 10 divided by 3xn squared plus 8xn. Aha! So see what I have now? I can now start doing my iteration. Let me go to the next page. What do we have? Xn plus 1 equal to what? What do you have last? Two xn cubed 4xn squared plus 10 divided by 3xn squared plus 8xn. All right, listen. Okay, now let's use table for this. It will be faster also. Don't just waste your time. So let's see how this will converge. So n time from 0 1. So am I xn plus 1, which is the whole of this sharp, everything. Okay, let's go. When n equal to 0, don't forget, I'll be having x, that's x1 equal to, if I put n to be 0, now the value I'm going to, now configure this in your calculator first. Do that. Just say 2x cubed plus 4x squared plus 10, then 3x squared, then press calculate. So the first x that you are going to be using will be x naught, okay? Here you substitute x naught, okay now?
Yes.
And our x naught is 1.5. So what do you get? Now give me 1.3733. Remember that by the time you want to substitute the next one, what I have here now is x1. By the time you want to substitute the next one, what you are going to be substituting will be this x1. I want to get that for n equal to 1. What will be here with x1 exactly? So just press equal to answer. That's I have 1.3653. x3 equal to answer. What do you have? 1.3652. x4 equal to answer 1.3652. Look at the rate of convergence, so fast. It will actually converge at what iteration?
3.
Exactly. That's why that's my best method of iteration. If they ask me to just choose, I'll just choose Newton Raphson. It converges faster than any other one. All right, that's that for that. So let us stop here so I'll not blow your head. So our next so our next class, like the next class we're going to be looking at will be Jacobi and Gauss-Seidel. Gauss-Seidel. So all this one have to do with matrices to iterate. You can use their matrix form or not. So in our next class, inshallah. Any question?
No, not at all.
So I will send the note to you now. Okay, so no question. All right.